Right. VXLAN EVPN. Oh, sorry. It's zoomed. VXLAN EVPN. Now, why VXLAN? That's the very first question we should ask ourselves. Why VXLAN? Do you have any?
Because the VLANs actually we can have only up to 4096. So in the service provider environment, having a multi-tenant requirement,
Very nice.
we will have to have more broadcast domains or something like that. Separate the traffic.
Nice. I appreciate. So let's see. What you said is also one of the point. So first thing is, in a data center, there are challenges. Like one of the challenges you said, we don't have that many broadcast domains. We don't have that many VLANs, maximum of 4096. And some switches don't even support that much. Some switches supports only 1005. Some supports only 2096. So there are limitations. Those limitations are not good for data center. So we are going to see those challenges, those limitations, those challenges now. Yeah. So today's data center is not same like what we had like 20 years back. Lot of virtualization. So the demand, the expectation is also very big now. For example, the applications. There are new applications which was not there in the early days. In the modern data center, we have a lot of applications, lots of applications, and they all need a lot of resource. And the application needs to complete the task in a very short time. So we need a data center which can fulfill this requirement. It needs to be, the data center needs to be a compatible one for this application. The data center needs to reduce the time to the minimum. So this is one big expectation. We call it as agility.
Agility.
What it is? Agility means how long it takes for an application to fulfill the requirement. For an application request to get fulfilled. So we need a data center that can reduce the time to the minimum so that the applications work, performance can be improved. And then data center today is growing in volume and size. The improvement need to be done to the data center so that even though the size, the volume changes, the data center needs to keep working always. It should not stumble. It should not decrease in the performance. It should have the ability, the data center should have the ability to keep working well. Even though when there is a change in the volume and size. Very correct. We call it a scalability. So we need a data center which is scalable, keeps working even when there is a big change, improvement done to the data center. And next is the demands, the requirements that newly comes in. New application workloads come in. When they come in, without affecting the existing application workload, the new application workload need to be taken care, should be adapted. So the ability to adapt the change when a new requirement, new application is added to the data center is expected from our data center, which is called as elasticity. We know what is elastic, which can be expended, elasticity. Elasticity is important. Yes, adapting to the changes.
New environment.
Yeah. Fourthly,
like giving it new new IP ranges, and it will not interfere with other applications, etc. Experimenting.
Yeah, new workloads, new applications, new workloads, and the network don't get tired. That is elasticity. Next, whatever the workload you put, how much ever you scale, consistently, your data center should keep running consistently. Very important. Not up and down and up and down. Consistent operation. Always. All 7 days a week. All 365 a year. The entire 24 hours a day. Consistent operational, which is called high availability. So we need highly available data center, always running 24/7/365. Should be consistent operational. So the other expectation is ability to provide access to your data center from anywhere, whenever you need it. Like you are trying to do for our server, no? From anywhere, if I need to log in, I should be able to log in. For that, you are trying to do some port forwarding method in my gateway. That's one of the example. But this is something bigger than what we are talking. Here, the entire data center and the resource needs to be mobility.
Mobility, and also the same thing, like should be secured.
Should be what? Secure. Correct.
Secured.
Correct. Should be safe. So the data center that have ability to provide data access where and when we need it is what mobility. Next is our data center should be able to divide the big physical fabric into small parts so that you can improve the network performance and security, as you said. when we do segmentation, even in Palo Alto, we learned that segmentation, zoning improves security. It minimizes the attack surface. So everywhere, we would like to do, we'd like to divide the network to improve the performance and security, even in data center. We need a data center that is able to divide, that is ready for dividing the big data center fabric into small parts so that we can improve the network performance and security. We call this as segmentation. So a data center should be available for segmentation. Not only that, as you said, we need to have very good security. The security part is very important. So your data center should be available. It should have the ability to apply the policies, the security policies, to prevent unauthorized access to our data center and the resources inside the data center. So security in data center is important. Finally, we want a data center that is ready for management and execution of the daily work without any human administration. This part is a little bit bitter for us, but that's what the data center needs. No human being, because human being takes time to do changes. Everything needs to be automated. And programmability. So we need a data center which is able to manage and execute data center routine workflows and processes without human being involved. All right. So this is another basic requirement of today's data center. So these are all the key points that we need to understand about a data center. It should fulfill these things. Now, to achieve these things, there are various steps taken. In the beginning, if you see, the spanning tree protocol is also one of the step to prevent loop, to provide availability. Even if one link goes down, immediately the other link comes as the forwarding port from blocking port. So there was some availability. There was some sort of fulfillment, slight fulfillment, like high availability, which was seen there. But that was not enough. Spanning tree is not fulfilling all the points that we saw. The big drawback of spanning tree is if you have multiple links, only one can be used. So we came up with another concept called VPC. Yeah, VPC. Virtual port channel. This is one of the next topic which we'll be seeing later after we finish this VXLAN topic that we started. What you are learning now is the climax. VPC is the grandfather of VXLAN EVPN. So the virtual PC or virtual port channel was a uh, kind of solution, but not really a complete solution. What kind of solution? STP, to avoid blocking port, we used to do port channel between two switches. We used to do port channel. We used to do port channel. But when it comes to more than two switches, when the third switch comes, even if you do VPC, even if you do port channel uh, like this, again there is going to be a loop. As a result, it is going to block this entire resource. So again, we are losing some considerable amount of resource. As a solution, the VPC came. VPC allows you to have a bundle like this. For that, these two switches should be combined as one switch so that it will appear like this. So they achieved this, and we call that as VPC. Combining these two switch, pairing these two switches as one virtual switch so that you can do a port channel. Actually, this is two physical switch, but it has been paired as one virtual switch. And that was a good advantage. You see, no more blocking. All these 4 ports are now available. All the 4 wires are now available for you to use. But again, in data center, are you going to have only 3 switches? No. You'll have many switches. This is only a solution between 3 switches. So VPC cannot be that solution that a data center really needs. We need something better. But still, I'm not saying VPC is a old technology. VPC is still existing in many, many data centers. VPC is widely spoken topic today. But I'm telling you that is a limited support feature. Though because it is new, people speak a lot about it, but it has got a lot of limitations. What? It's a layer 2 technology. That's one limitation. Another thing, what? It can be only between 3 switches. It's a lot of drawbacks there. We'll talk about that when we learn VPC later. So later, Cisco came up with Cisco's fabric path. What is Cisco's fabric path? Cisco's fabric path is you having many switches like leaf and spine architecture. It need not to be always leaf and spine. If it is leaf and spine, it is much appreciated. So even though we got redundant wires, there is no blocking. There is no blocking. We got redundant wire. You see, there are redundant wire path between one leaf and another leaf. If you want to go from one leaf to another leaf, you have at least 4 wires, 4 paths, redundant paths. If it is STP, you would have got blocked. This 3 might have got blocked. Only one will be available. But with fabric path, all are available. See, they have given a nice name to it, fabric path. See, fabric path is also a very good concept. I like fabric path more than VPC because you see many switches can be involved. VPC is only 3 switch. Fabric path many switch. But Cisco is now silent about this feature. Why? They want you to buy ACI. If you know fabric path, if you know VXLAN, you will not buy ACI. You won't buy it. They won't make money. This fabric path is very simple, easy to configure, very easier than VPC, and more big advantage, big benefit than VPC. Like VPC, this is also layer 2. It's not layer 3. So that's one limitation. That's why we need VXLAN. But Cisco never talks about this now. Earlier, they used to talk a lot when there was no VXLAN, when there was no ACI. They used to talk, promote Cisco product by mentioning this fabric path. But today they are very silent because they don't want you to know this. This is easy to configure and more benefit than this VPC. More benefit. You see, all these links are available for you to use. No blocking. So from VPC came to fabric path. So this fabric path has got a limitation. As I said, no layer 3 support, no multi-tenant, no multi-tenant. That is the reason why we are in VXLAN now. What is multi-tenant? Having multiple control planes, layer 3 isolation, layer 2, layer 3, layer 2 to 7 isolation, complete isolation. They will all be using one physical fabric, multi-tenants. Physically, they are using one physical topology, physical fabric, but logically they are in different fabric. They are in different topology. There is no connection between one virtual fabric and the other virtual fabric. That is what we call it as multi-tenant. Okay, so
Yes, sir.
VXLAN can fulfill that multi-tenant requirement. VXLAN also supports layer 3. Much more advantage with VXLAN. We are going to learn VXLAN in detail. As of now, we'll stop about VXLAN here. Now, next is we got different type of topology design in a data center. You might have seen something like this: core layer, aggregation or distribution layer, and then access layer. VXLAN can fit in this topology, any topology actually. Recommended is the leaf and spine, which we saw above, right? So we used to have a port channel so that we, because there will be more traffic between these two switch. This we call it as core layer. This we call it as
Distribution.
aggregation or distribution layer, where we have down here is layer 2, up here is layer 3, and this is one classical 3-tier design. Now another design that we are trying to have in future, present and future, is this 2-tier design, which we also call it as close fabric design. in which we will have many leaves. Let me make it small because I want to draw more leaf. And in this leaf, the above is layer 3, below is layer 2, and all the leaf depends on the spine to communicate with another leaf. I don't want to have more spines because I don't want to draw more cables. So let's have 3. And all the leaves connects to all the spine. Spine don't connect, leaf don't connect. In VXLAN, we don't connect. In ACI, if you connect, there is a protocol. It will sense that you have connected between leaf and spine. It will automatically block the port. ACI is automation, right? So ACI have to do that. That is why we call it as automation tool, orchestrating tool. It's an automation which is sending them people out of their job. Automation. That is ACI. Now we got spine here and leaf. This is close fabric design which is recommended, but for ACI it is mandatory. For VXLAN EVPN it's not mandatory. For ACI you are dependent on the hardware also. ACI automation tool, the orchestrated tool, cannot work with Catalyst Switch and uh, uh, iOS XR, iOS XE. There is a specific series of 9000 that is meant only for leaf. There is a specific series of 9000 Nexus which is meant only for spine. So there are a lot of hardware dependency, costly as well. ACI. But VXLAN EVPN is cheaper solution. No automation, everything we do. At the same time, it is cheaper. It is cheaper because you can have your existing switches. You don't need to buy some special device for having VXLAN EVPN. If VXLAN EVPN is supported, you can use it. It can be XR, it can be XE, it can be Nexus. So you are not dependent. Whereas the other one is that the ACI is a dependent solution where we spend a lot of money to buy. That is what makes Cisco happy. It's an orchestrator, ACI. EPIC is an orchestrator, and which can do that same VXLAN EVPN with less effort. You don't need to know concepts. You need to simply go to the tabs and fill the pages. It's going to be same VXLAN EVPN which that orchestrator going to create for you. Here you do the tenants manually. There the tenants need to be the tenants are created through web interface. Through GUI you just put some name and create tenants. Here you need to map those VLANs to VNIs. There you call it as EPGs. EPG will do those things for you. All right. So The working principle of ACI is nothing but VXLAN EVPN. Fine. Now, knowing this VXLAN EVPN is like you're not just a pilot, you are also an engineer, aeronautical engineer with a mechanical engineer. So if anything goes wrong with the carpet instruments, you still know how to land the flight. Without knowing this VXLAN EVP and learning ACI is just you are an aeronautic engineer, you know how to fly the flight, but if something goes wrong with the instruments, you will struggle. You will not really know how they're working behind the screen. So in short, what I'm saying is VXLAN EVPN is a good approach to understand ACI better. Now let us get into the VXLAN EVPN itself. What is VXLAN? Virtual extensible local area network. VXLAN. VXLAN. Virtual extensible local area network. VXLAN. VXLAN is a layer 2, but it operates on top of layer 3 overlay tunnel. So you're going to have a layer 3 overlay tunnel. Inside the tunnel, you are going to have this layer 2 communication. VXLAN is layer 2 in layer 3 overlay tunnel.
To say it will be like the broadcasts are happening over layer 3, right, sir?
Yeah, if you see a bump traffic, they do broadcast, yes, but not exactly broadcast. There will be grouping with multicast. It does multicast, not broadcast. Even when there is a layer 2 broadcast traffic comes, it will be multicast inside the layer 3 tunnel, layer 3 overlay tunnel. It will be multicasted. So you are talking about broadcast of traffic coming from an end device. When an ARP
Yeah.
request, for example, comes, when an ARP request comes, it comes to the leaf, and if leaf do not know the IP address of that ARP request MAC address, it needs to now flood it, but it won't be flooding to all. It will be flooding within that tunnel reachable tunnel endpoints. The tunnel endpoints are identified either by ingress replication method, where we manually say where the tunnel need to end, or using a BGP control plane, or by multicast grouping. We'll talk about those things in detail later. So for your question, yes, all your layer 2 conversations are going to be over this layer 3 tunnel. That's the answer. Now, to adapt this VXLAN feature, there is a dedicated port number given for this VXLAN service. So whenever VXLAN wants to use this layer 3 tunnel to transport layer 2, which is what we called as VXLAN, there is a special port number because it's layer 3, I can say IP/UDP tunnel. And the port number is 4789. Easy. 789. 4789. 4789. This is according to RFC 7348.
Sir, one point, sir. You told
Yeah.
IP UDP. So does it support both IPv4 and IPv6?
That, yes, it is. It does.
Okay.
It does. But I have not seen one example. It should, according to me, the RFC will be different for that. I need to check that. Definitely IPv6 will support this, but I have not seen one anywhere. VXLAN with IPv6, I have not seen anyone talking about that. Let me also check and get back to you on this.
Okay.
All right. But I know very well if IP version 4 can do this, IP version 6 is easy because it's an extendable header.
Okay.
And the port numbers are UDP. The layer 4 is UDP, so it is possible. Okay, and that is a very good question. Your question was, can we have this tunnel itself to be built
IPv6.
using IP? It's not there. You're not talking about the traffic that goes through the tunnel. You are talking about the underlay tunnel
Using IPv6.
that is built. Can it be an IPv6? Meaning, in another technical word, can that VTAP address, virtual tunnel endpoint address, can be an IPv6?
Yes,
This is the question. So here we have 18-page PDF from Cisco saying configuring VXLAN with IPv6 in the underlay, which means it is possible. See, the VTAP address can be where it is. The VTAP address can be an IPv6 address. This is the VTAP address. So it is possible, but not much spoken in the field today to have an underlay of IPv6. We'll try maybe in the end later when we have enough time after we finish all the necessary topics.
Okay, sir.
We'll talk about that. So the port number is 4789, but not many people use that standard port number. They try to use different port number because it is easy to tell what port number to use. The configuration commands are simple. They use some user-defined port numbers. Now, VXLAN, one main reason why we need VXLAN, one of the reason is the extended VLAN namespace. VLAN is limited, like you said, only 12 bits. With 12 bits, only 4096 VLANs. Whereas the VXLAN is 24-bit size. So you got more space here. More space. 24-bit size. You got more space. It's not just double the size. No. That was 12-bit. This is 24-bit. It is double. No. In binary, if you move from 12-bit to 13-bit, then it is called as doubling. You know that, right? If 12-bit can give you 4096, 13-bit will give you 8192. Double. This is not just double. This is many times double. 24-bit. So really a very big number of layer 2 domains you can have. Now, VXLAN with 24-bit, it can provide you 167777216 different IDs or values. Yeah. So VXLAN, another advantage of VXLAN is layer 2 multipathing. We can have equal cost load balancing, ECMP. You got layer 3 ECMP, you got layer 2 multipathing. So there is no need for STP to prevent loop. Let me write it down. It allows to have layer 2 multipathing. So there is no need for STP, isn't it? If multipathing is allowed, why need for STP? No need. Only when there is no multipathing, then to prevent loop, you need to block and keep one active. So no STP. Next is, how does it provides this layer 2 multipathing? By using the underlay layer 3 ECMP. Because it is using layer 3 ECMP, you don't need STP. Have you seen anywhere blocking in layer 3? No. Even if you have many redundant paths in layer 3, you will not find any blocking. So over the layer 3 ECMP in class architecture, leaf and spine architecture, see, that's a very important thing. If you want layer 2 multipathing, you need a class architecture. You need that leaf and spine architecture. So in the leaf and spine architecture, you are going to have a layer 3 underlay like OSPF or ISIS, some protocol, whether to use ISIS and or OSPF. Using that underlay, you will have multipathing. Because you got the underlay multipathing, ECMP multipathing, the overlay, the VPN, the tunnel, the VXLAN tunnel is also now going to have multiple paths, layer 2 multipathing. Now, what is the advantage? See, this layer 3 ECMP is possible if you have class architecture. What if I have internet? See, there's an internet cloud here. And in Trivandrum, I have an office. In Trivandrum office, I have a lot of computers. And I have another office in Goa. I got a lot of computers. Now, these are the two sites in India I have, and I'm connecting through the internet. Now, you see, from Trivandrum, early morning, I took flight and I went to Goa. Now I'm here. And I'm logging in. I did not take this computer from Trivandrum. It is a local computer in Goa. So here what I do is I log in with my domain name, my credentials. I'm able to see the same computer, same desktop, same everything that I was having in Trivandrum. This is what called as vMotion in VMware. For this to happen, what you need is a layer 2 tunnel between these. A layer 2 tunnel.
Okay.
So with only when you have a layer 2 circuit, there won't be layer 2 address change, isn't it? When you have layer 3, for every hop the layer 2 address changes. Yes or no? When you have many routers in the middle, when there is a routing in the middle, there will be layer 2 encapsulation, decapsulation. There will be change in the source and destination MAC address. Do
Yes,
you
yes,
do you agree?
yes, sir.
Do you know that? Yes. For vMotion, that is not acceptable because with the MAC address only every profile gets binded. So the MAC address should not get changed. The source and destination MAC address should be same till it reaches the destination, till the packet reaches from the server here to the server here. It should be same. Only then it can give the same VM to me here. If the layer 2 breaks, then vMotion is not possible. This is the big disadvantage of, this is the big advantage of VXLAN. VXLAN does not break the layer 2 adjacency requirements. Yeah. Next. As we already spoke, VXLAN allows for multi-tenancy. You can have many tenants and you can separate one customer traffic from the other over this one common physical underlay fabric. Not only that, you can use the same VLAN numbers for these tenants. It won't conflict. Why? Because they are in separate fabric virtually. We separate the customer traffic, but the underlay physical fabric is a shared one for all of them. The overlay is totally separate for one customer and the other customer. The overlay is a virtual one. Because it is total isolation, one customer VLAN number and the other customer VLAN number, if they have same, it won't conflict. So for each tenant, you can give 4096 VLANs now for each tenant. Did you get that point? Multi-tenancy.
Yes, sir.
Now this, okay, let me write
Just
down
like
that
we are
point. I did
doing the
not do it.
VRF only.
Exactly here also the same VRF only we'll be doing. VRF only we are going to do here also. We are route target, route destination. You're right. Okay. The next is with VXLAN you can have virtual workloads on the physical network. That's what I was saying, virtual grouping, virtual workloads. So with VXLAN, you don't need to be dependent on the physical topology. That's what I want to say. Using that physical topology, you can have your own virtual workloads. Whatever the topology that you want to have, you can have it in a virtual manner over that physical underlay. All right. Now, this is the last point. Yeah, now what we are going to see is the last point about the VXLAN feature. And this is very important also. When we talk about VXLAN, not always EVPN will come into picture. VXLAN have two flavors. One is simply VXLAN, where we use only multicasting and we always flood and learn. Flooding and learning, always flooding and learning. That's one method, one of the flavor. Second one is using a control plane to provide you the info so that you no need to flood. That control plane is provided with the help of the routing protocol BGP AVPN. Yep. So we have these two flavors, flood and learn and BGP EVPN. Okay. So